In this video, we discuss an application of linear systems of equations. At a local buffet, a child's plate cost $4.50, while an adult's plate cost $6.70. If 395 plates were served, and a total of $2,096.50 was collected, how many of each type of plate was served? Anytime I start an application problem, I always begin by identifying my unknowns. Specifically, I want to assign variables to the quantities that we're looking for. In this problem, we are looking for how many of each type of plate was served. Specifically, we are looking for the number of plates served to children and the number of plates served to adults. So let's assign a variable to each of those unknowns. We will let x be the number of plates for children, and I will let y be the number of plates for adults. Beautiful. Now that we know what we're looking for and we have placed variables for those values, we can proceed by organizing our information. Often, I like to organize my information in the form of a chart. It kind of puts everything together in one nice little package. So let's put a little chart here. I have a chart where the first column consists of the number of plates, the second column consists of the cost per plate, and the third column consists of the amount collected. Now, the amount collected is simply a combination of the first two items. Namely, the amount collected is simply the number of plates times the cost of each plate. So we're just going to multiply the objects in the first and second column to get that in the third column. Let's go through this. So, first of all, the number of plates. Well, we actually have two different number of plates to consider. We have the children plates and we have the adult plates. How many children plates were we serving? Well, that was unknown, and we let that be represented by the value x. What is the cost per plate? The cost per child's plate was $4.50. And so that means the amount collected is x times $4.50, or if you like, I'm going to write it as 4.5x. That's the cost times the number of plates. That represents the amount collected from the children's plates. Let's continue. Looking at the number of plates served to adults, we also let that be a variable. That was the variable y. And the cost per adult was $6.70. Thus, the amount collected for the adult plates was 6.70 times y, or simply 6.7y. Wonderful. So now that we have the information organized in a chart, I want to write two equations. And our equations always come, well, not always, but often come from this information here in the first column, and then the information here in the third column. So we need a little more information in that first column before we can write an equation. What do we know about the number of plates? Well, we know if we take the number of children's plates plus the number of adults' plates and add those two values together, it gives us the total number of plates that were served. And we actually have that value in our problem. 395 plates were served, so that means that if I add x to y, I get 395. This creates the first equation in our system of equations. X, the number of plates of children, plus y, the number of plates for adults, equals the total number of plates, which is 395. All right, let's look at that last column. In that last column, we had 4.5x and 6.7y. And these two values represented the amount of money we collected from children and the amount of money we collected from adults. And so if you add up the amount of money collected from children plus the amount of money collected from adults, you will get the total amount of money that was collected. And again, that's also in our problem. We are told that we have collected, or the buffet has collected, $2,096.50. So that gives us the second equation for our system of linear equations. Our second equation is simply 4.5x plus 6.7y equals $2,096.50, which I will write as 2096.5. I don't need that extra zero. This is the system of linear equations that we can use to solve this problem. So how might we go about solving this? Well, we can either use the substitution method or the addition-elimination method. I think I'll choose to use the addition-elimination method. More than that, I often find that students don't like equations that have decimals or fractions, and so I encourage them often to clear out fractions or decimals before you begin. In the second equation, notice you have decimals. We can clear this out easily by bringing our decimal points over one space. And effectively, what we'll do that is if we multiply each of the terms in our equation by 10. So if I multiply each of our terms by 10, that has the same effect as moving the decimal place over one position. So that will give us the new system. X plus y equals 395. And 45x plus 67y equals 20965, or if you like, 20,965. Now let's use that addition-elimination method. Again, if you like, you could have also used the substitution method. In the addition-elimination method, you want to add the equations down to cancel a variable. If I want to eliminate a variable, perhaps I'm going to choose to eliminate my x's. And to eliminate my x's, I must multiply my first equation by negative 45, so that when I add down, the negative 45x will cancel with the positive 45x. But if I do it to that first term, I have to do it to every term in my equation. Doing so, that creates yet one more system. So let's write down that system that we get. This gives us negative 45x minus 45y equals, and multiplying this on a calculator or on a piece of scratch paper, this gives us 17,775. Rewriting that second equation, 45x plus 67y equals 20,965, gives us the system of equations that we can now add down vertically to eliminate the variable x. Negative 45x plus 45x cancels. Negative 45y plus 67y gives us 22y. And negative 17,775 plus 20,965 gives us 3,190. We finish by solving for y, so let's divide both sides of this equation by 22. And that tells us that y equals 145. Let's check that with a calculator. Now go back and solve for x. So we replace this into one of our original equations. The top equation seems the simplest to me, so I'll retake x plus y equals 395. And since I'm told that y is 145, I can solve for x. X plus 145 equals 395. Do a quick little subtraction. We subtract 145 from both sides. And that gives us that x equals 250. Going back, we had labeled our variables, x and y, at the beginning, and so now we can use those to state our conclusion. X is 250. That means there were 250 child plates served. Y was 145, and recall Y was the number of plates for adults, so that means there was 145 adult plates served. Not that bad.